I'm looking at graphing numeric response number 2. Now, this one is on page 5 of your numeric response booklet that I gave you in class on Friday. This one says some students do an experiment to find the focal length of a converging lens. They set up an optical bench and measure the image distance as a function of the object distance. So here would be our object. This is a candle shining light through this lens, and it's going to project an image onto the screen. What we're doing here is manipulating the object distance, seeing how the image distance responds to that. That's our data. And then trying to find that relationship there so that we can ultimately, I think this question asks us for the focal length of the lens. We're not going to plot DI versus DO. Rather, we're going to create a new table of the inverse of DO and DI, and then plot that graph, the reciprocal of the image distance, the reciprocal of the object distance, 1 over DI, 1 over DO. Now, you can see in this one that you are not given the trend line. So for this one, we have to identify our ordered pairs for each data point. So let's do that. Remember, if we're given the trend line, just pick 2 points on the trend line far apart, do the slope. If we're not given the trend line, then we have to do our stat edit 1, stat calc fork thing from our calculators in order to determine the slope given all of the data points. So I'm going to identify the ordered pairs here now. You can see on the x-axis that our interval is 0.1, 0.1, 0.2, 0.3, 0.4, 0.5. So this one would be 0.65. And on our y-axis, looks like we're going up by 0.2s. 2.2, 2.4, 2.6, 2.83. This one would be 3.2. Now the second one here, the coordinates would be 0.85 and 3.1. The third data point, the coordinates would be 1 and 3. The fourth one, the coordinates would be 1.15 and 2.6. Make sure you can get these coordinates. And this one would have coordinates of 2 and 2. We don't even need to draw the trend line on this. We can just punch these numbers into our calculator, that stat edit 1, stat calc 4 function, and that will spit out for us the slope of the graph. It works out to be negative 0.993, and the y-intercept is not 0 here. It works out to be about 3.8255. So because it's not 0, we want to include that. Now this would be a straight line graph if we were to draw a trend line. Just roughly sketch it there. Don't need to, but it would be a straight line if we did, which means that we do what we do. 2 columns, graph and class. The equation from the graph, as always, will be y equals mx plus b. The y-axis is the reciprocal of the image distance. M stands for the slope. The x-axis is the reciprocal of the object distance, and because there is a y-intercept here, we have to include that. No big one. Just add it on like you always would. Now the equation from class that has 1 over di and 1 over do in it is our thin lens equation. 1 over f is equal to 1 over do plus 1 over di. Let's rearrange that to solve for 1 over di, because that's what we solved for over here in our graph equation. So let's say 1 over di, or let's go 1 over f minus, 1 over f minus 1 over do. Take the 1 over do over to the other side. Gives us 1 over di. Let's change the order of that a little bit. 1 over di is equal to, I'm going to say negative 1 over do plus 1 over f, just so that it's all in the same order as we have over here. 1 over di, 1 over do, and then something else. 1 over di, 1 over do, something else. All right, let's cross off 1 over di because it's in both, 1 over do because it's in both. We're left with the slope is equal to negative 1. Theoretically, We actually found that it was 0.93, but that's pretty close to -1. Theoretically, no matter what the data looks like, it should work out to be -1. But as you know, real data doesn't always produce what we expect to get. It's close though. Now, the y-intercept here, 1 over DO plus B, 1 over DO plus 1 over F. We're looking for, in this question, the slope of the line. This should say in scientific notation. So A decimal B was negative 9.3 times 10 to the negative 1. 9.3 would be A and B. And then it says, what's the experimental value of the focal length in centimeters? So we're going to do F is equal to 1 over the y-intercept, or 1 over 3.8255, the number that my calculator spat out when I started this question. Works out to be 0.26 meters, which is 26 centimeters, which will bubble in right here, 26. So our answer would be 9326, 0.93 for the slope, and 26 centimeters for the focal length.